In this video, I'm going to solve a subnetting problem where I'm looking for the last valid host on the subnetwork 192.168.82.80, and the subnet mask is 255.255.255.240. Now, it's already telling me this is my subnet ID, and it's also telling me that this is my subnet mask. The first thing I always want to do in problems like this is I convert my subnet mask to binary. There is a video that will show you how to convert decimal to binary, but the short answer here is that all of my 255s are 8 ones, and a 240 happens to be 4 ones and 4 zeros. So my subnet mask looks like this. The next thing I want to do is I want to look at this and identify where my octet is that I really have to do a lot of the work. Well, it's not going to be my first 3 octets. Those are all ones, which means they're all part of the network side. And as a matter of fact, I can draw a line here between my ones and my zeros and tell what part defines the network and what part defines the host in my address. I know that when I'm looking at this, the network part is never going to change. From the first host to the last, from the network ID to the broadcast, that host will never change because the network has to stay the same. Otherwise, we'd be on a different network. So my answer is going to be 192.168.82. something. I need to figure out that last octet in this problem. So what I want to do is I want to convert my IP address to binary, but I don't need to mess around with these first 3 octets. I know they're staying the same. It's this .80 that I want to look at. So in order to convert 80 from decimal to binary, I know that 128 doesn't fit into 80. I do know that 64 fits in, and it actually leaves 16 left over. 32 doesn't fit, and 16 fits. So 01010000 is 80. Next thing I'm going to do is I'm going to draw my N1LB chart, which helps lay out the 4 components that I might be looking for in this address. The network side never changes. So the network ID in the broadcast and the first host and the last host, they'll all have the exact same network ID. So I can leave this unchanged all the way down. And then the host portion is the part that gets changed up. The network ID always represents the smallest possible number in the host portion of the address. The smallest possible number I can make is all zeros. The broadcast address is always the largest possible number I can make in the host portion of the address. So it's all ones. These are my bookends. The start of my network and the end of my network in binary. So in order to see what the very first usable address would be, it would be the smallest number I can write that isn't already taken up by my network ID. And the last valid host is going to be the largest number I can write that isn't already used up by my broadcast. These will always be opposites. And in this problem, I happen to be looking for the last valid host, which is right here. When I convert this number back from binary to decimal, I'll have my answer. So, looks like there's a 64, a 16. We already know that equals 80 from up here when we did this math. And I'm also adding in an 8, a 4, and a 2. So there's 10 there. And my answer is 94. The last valid host on this subnetwork is .94. If you're ever looking at a problem like this and you want to check your work, this is always even, this is always odd, this is always even, and this is always odd. Broadcast IDs are always an odd number, network IDs are always even, and they alternate. The first usable host on a network is always an odd number, and the last usable host is always an even number, because it's the one just before the odd numbered broadcast. So that makes sense. And checking my work, it's an even number, so I know that that answer does pass that little parity check there.